Alright, so this is a brief little recording on how to use Excel to solve a linear program. And so we're going to solve the linear program that we looked at in class, this work schedule problem. Excuse me, the work schedule problem, where we were trying to minimize the sum of 6 unknowns, each unknown representing the number of people starting work on the ith shift. Okay. So I've got LibreOffice installed on my machine, so I'll go ahead and click on LibreOffice. And now I like to reserve several areas for building the linear program. The first part is going to be to work with the objective function. And so I can write objective function up here. Second part will be for the constraints. And then lastly, we're going to do some computation. Okay, so in the objective function we have 6 variables. Let's go ahead and list them: x1, x2, x3, x4, x5, x6. We really don't need that much space for these. Let me take a minute and pull them in a little bit. One more. Maybe one more. Okay. Good. Now we're going to leave these blank because these are going to be the cells where we actually put in the current values of our variables. But on the next line we'll actually put in our objective function coefficients. So in this case we're just taking the sum of the 6, right? So that'll just be a 1, a 1, a 1, 1, 1. So our coefficients are just all 1. Okay, and now this is going to be actually the objective function itself. We might leave a little more space here. And so if we put in equals sum product, and now I'll use dollar signs around the variables that don't move, which are B3. See if those are cells B3 to G3, B3 to G3, comma, and then the coefficients are B4 through G4. I guess I didn't really need to make those dollar signs, but that's fine. Okay. And now our constraints. I'll go ahead and put the coefficients for our constraint matrix in here. So you see the first one's just going to be 1, all zeros, and then a 1 with x6. So it'll be 1, zeros, and x6 has a 1. That's going to be a greater than or equal to, and that greater than or equal to is just my reminder to myself what's happening. And then we have an 8 on the other side. Okay, so let's go ahead and pull that in a little bit, and pull that one in a little bit. Okay, and now we'll have x1 and x2 in the next line, and then x2 and x3, right? x2, x3, x3, x4. So this is x2, x3, x3, x4, x4, x5, and then x5, x6. Go ahead and put in zeros everywhere else just to be consistent here. 0, 0, 0, 0, 0, 0. Okay, we're just about there. Oop, I see I needed more constraints than usual. Let's take that out. Okay, put the computation down here. Computation. Okay, so now we have our greater than or equal to, greater than or equal to, greater than or equal to. Oop, I see a missing 0. Greater than or equal to. Okay, good. And now we'll go through our right hand side. 8, 7, 6, 6, 5, 4. Good. And now we're going to assume that all the variables are positive, or non-negative anyway. And so here our computations are going to be one computation for each constraint, right? So here's where it's going to be important to not use dollar signs. So sum product. We'll have dollar signs for the first row B3 to G3, right? Because those do not change. But now I'm going to be using row 7, right, for these constraints. So that's that B7 to G7 will change. Okay. And so now I can just copy and paste. So if I copy, paste, paste, you'll see the numbers are going up. Paste, one more. Let's see, we need to go down to 12, so one more. Paste, okay. And similarly here, we could just say this is equal to I7. Okay. Copy and then paste. I think you could paste several things together, but just to make sure we don't have that many. Paste. Okay. So now we're ready. We have our objective function. Go ahead and maybe boldface that. Boldface that. Boldface that. Good. Now we're ready for the solver. So I've got my options up here. Go to my solver, and hopefully your solver looks similar. So we're going to optimize where the objective function is, and that is computed in B5. So we want to go to B5, and we'll go ahead and put a dollar sign on there. That means it's not going to change, and we actually want to minimize that. Then we're able to change B3 to G3. I'll go ahead and use dollar signs there. Okay, and now our cell references are just going to be the computation version, not the ones up here. So that starts with B14 and goes down to B19. B14, B15, B16, and so on. B17. Scroll down a little bit. B18 and B19. Good. And now let's scroll back up. We'll get these changed over. Greater than or equal to, 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 greater than or equal to. What's that one going to be? Greater than or equal to, oh, good. And then this will be C14 through 19. C14. Oops. The numbers should match. C14, C14, C15, C16, C17, C18. Now there's also a way you can, I think you can, there are shortcuts for this, but that's okay. We don't have that many. Good. So now let me check the options just to be sure. Assume variables as integers, we're not going to use that. Assume variables as non-negative, we will assume that. Okay. And now we're ready to solve. And there we go. The result is 19. So we'll keep that result, and we see here we want 8 people on the first shift, 1 person coming into the second, 5 on the third, 1 on the fourth, 4 on the fifth, and then we don't need anybody else in the sixth shift. And that is our optimal solution. And that is how you use LibreOffice or Excel to solve a linear program. Be sure and save your results, by the way. File, save as. We'll save it as, in this case it was scheduling 1. XLS. Good. Alright, so good luck. Give it a try. It's not too hard. And I'll see you later.